Hello students, good morning. Welcome to grade 8 science classes. I am your physics teacher. I am going to start the new chapter in our science textbook. Chapter name is Force and Pressure. Okay students, before starting our class, I want to ask few questions which we are experiencing in our daily life. Question is, while we are entering into a room, we used to open the door. What we are doing there? Yes, we are pushing the door. Okay, after sometimes we used to play football. How you people used to play football? By kicking ball. So what we are doing there? We are pushing a ball. Likewise, if we are playing cricket, we used to hit the ball, which is giving some kind of push. Clear? So for example, once you enter into any shop or somewhere, you can notice that something wrote on the door. What is that? Yes, push or pull. So you may have doubt, what is that push or pull? See, push or pull is nothing but it's called force. So force is nothing but it's a push or pull on an object. Yes, you may have doubt, what is the object? Yes, object means where we are giving force, it is what we call object. For example, if we are open the door, where the door is the object, where we are applying some kind of push or pull. So force is nothing but push or pull on an object. Yes, right now I'm going to say one important thing which we are using in our daily life. Okay, see, I already told you we used to push the door or pull the door. See, if while pushing, two objects are acting there. One is my hand and another one is door. Clear? Likewise, when we are kick a football, two objects are interacting there. One is our leg and another one is football. So what you understand, it means if we are applying a force on an object, there should be two object interaction. Yes, there are two object interaction. Object number one is a door and object number two is my hand in opening the door case. If we are taking the kicking a football case, you can notice that leg is object one and football is object two. If we are taking hit a cricket ball is object one and bat is object two. So force is possible only when the interaction between two objects are there. So force is due to interaction between two objects. Okay, my dear students, I'm going to show one example. Listen very carefully. See, this is a cardboard box. This is a cardboard box. Clear? I want to push or pull. So here onwards, no need to say push or pull. We have to use the term force. Yes, I am going to apply force on an object. That object is cardboard. Yes, here we have two objects. One is force applying my hand and one is cardboard. So force is due to interaction of two objects. So I'm going to give force. Clear? How much force, the strength of force which I giving to the cardboard box is called magnitude of force. It's called magnitude of force. So magnitude of force is nothing but how much the strength of force I'm giving to the cardboard box is what we called magnitude of force. See, I'm going to give you a force which is 6 Newton. How much? 6 Newton. So you may have doubt, what is sir Newton? Newton is the unit of force. Each and every physical quantity we have unit. Likewise, for length we use meter or centimeter. For mass we use kilogram. Likewise, force is, the unit of force is Newton. So you need not to worry about that. We will discuss in future classes. Right now, I am giving a 6 Newton force in one direction. At the same time, again I am giving another force on the same direction. See, 10 Newton. So total force act on this cardboard box is, what we have to do is 6 plus 10, which is equal to 16 Newton. So my point is, see, if we are applying force, if you want to apply more than 1 or 2 or 3 or force, so the total force, how to find total force? For total force can find by adding all those force. See, one more example is, one man is giving force in this direction, which is 6 Newton, and another person who is giving force in this direction is 20 Newton. So how to find the total force or net force? See, it's very simple. How to find net force? Listen very carefully. See, two forces are acting in different direction. As I told you before, if two forces are applying in same direction, we have to add for getting total force or net force. Once again, if we want to find total force, the both forces are acting in same direction, what we have to do, we have to plus both the force to find net force. Likewise, if two forces are acting on opposite direction, for example, one person is giving force in this direction and another person is giving force in this direction, then force is acting on opposite direction. So how to find net force? That is what my question. Very simple. To find net force is we have to subtract these two forces. How to subtract these two forces? This is 20 Newton. Newton is the unit of force. No need to write. Minus this direction 6. So 20 minus 6 is equal to 14. Okay, what you understood from this, if we are applying force on same direction, we have to add all forces. Likewise, if you are applying force in opposite direction, what we have to do, we have to subtract the both forces. Then we will get the term net force. So now I am going to show one experiment. Okay, my dear students, now we are going to play tug of war. Yes, this is rope. This is center part of that rope. Here, 3 persons are standing, 3 persons. Likewise, here also 3 are standing. Sure, why we are you playing the tug of war? To applying force. But important thing is that 3 persons give force in this direction and another 3 person is giving force in this direction. So which means forces are acting on opposite direction. Yes, I'm going to, the 3 person going to give force in that direction and 3 are giving force in this direction. See, the strength of force given by this direction, person who are standing in this direction is 100 Newton. Likewise, the person who are standing in this direction also giving 100 Newton. So my question is simple. In which direction the rope moves? In this direction or this direction? We can name this is A group and this is B group. In which direction of object will move? Means that rope will move. Yes, we can say that. How to find the net force? Before I told you, net force can be calculated. If is it in opposite direction, we have to minus, subtract. So force by A group is 100 and force by B group is also 100. So 100 minus 100 is 0. It means there is no net force acts on the rope. It means the rope will not move. So that is what happened in tug of war. No, if it is like so, no one will, what to say, success. So what we have to do, 3 person in this group are so lazy. So they are giving little bit less force, that is only 50 Newton. Then we can calculate the net force. Let's see how to calculate net force. It's very simple. Net force is equal to 100 minus 50, which is equal to 50 Newton. So it means net force is 50 Newton. So you may have doubt in which direction this rope will move. Very simple. Who is giving more force? In that direction the rope will move. So for A, group A is giving more force, so net force along the direction A. Okay, from this it is very clear that if forces are acting in same direction, the net force can be calculated by using summing up all forces. If forces are acting along the opposite direction, the net force can be calculated by subtracting that force. My dear students, see why we are applying force to an object. Why we are applying force to an object? Yes, we have something to get. Yes, what is that? Let's see. For example, I have a car which is repaired. So what can I do? I want to move that car. So no petrol is there. What you used to do? You just push the car. For example, consider this is a car. This is a car. This is not working. So what I have to do? I have to give some force on it. If I give force, it will move. So what effect I get? Because of force, that object which is at rest starts moving. So effects of force, the point number 1 is by applying force, we can move the object which is at rest. That is point number 1. We can take many examples. Likewise, in our home itself, we have a table which is stationary there, rest there. So I want to make it move. How to move? Just to give some force on it. So effects of force, point number 1 is by giving force, we can able to move one object, whatever be the object. Clear? Then point number 2, if an object is moving, I want to make it stop. For example, one person who is riding a bicycle and coming in front of us, I want to stop, which is moving very slow, okay? Don't stop the bicycle which is moving very fast. If it is moving very slow, how can I stop that? By giving force in opposite direction. For example, one bicycle is here, one bicycle, which is moving in this direction. I want to make it stop. How to make it stop? By giving force in opposite direction. So if you are applying force, we can stop the object, moving object. So 2 effects were there. One is by giving force, we can move the object which is at rest. And second one, by giving the force, we can stop the object which is at moving. And one more thing, I want to increase the speed of the bicycle. How can I increase the speed of the bicycle? By giving more force. So point number 3, by giving more force, we can increase the speed of the object. These 3 effects. Once again, point number 1, by giving force, we can move the object which is at rest. And point number 2, by giving force, we can stop the object which is at motion. And point number 3, we can give the force to the object to increase the speed. These are the 3 important effects. One more effect we have, that is what I'm going to show. See, listen very carefully. I have a ball in my hand. I'm going to press, I'm applying force on the object. Yes, I'm going to apply the force on the object. If I applying force on the object, I can notice that the shape of the ball is changing. So what you understood from that? If you are applying force on the object, the shape of the object can be changed. Yes, many examples are there. Some relatives came to my home. Suddenly I don't have any snacks or something. Then what I'm going to do? I'm going to give them lime water. Then how to give lime? Nothing but we are squeezing a lemon. So if I give force to the lemon, the extraction inside the lemon comes out. How it comes out? While squeezing, I'm giving force. By giving the force, the object shape changes. So you may have doubts. Is there any more example? Yes, we have. For example, so you people are well clear about that clay. So if you are applying force on the clay, we can change the shape. Clear? So if you are applying force, we can change the shape of the object. So total number of effects of force are 4. Point number 1, by using a force, we can move the object. By applying force, we can stop the object. Point number 3, by applying force, we can increase the speed of the object. Point number 4, by applying the force, we can change the shape of the object. Okay students, today we discussed what is force, and force is due to interaction of object, and third one is if force is acting on same object, the net force will be sum of forces. If it is in opposite direction, the net force will be subtracting those forces. And along with that, we discussed effects of forces also. Force, by using force, we can change the motion of an object. We can change the shape of the object. Many things we discussed. Okay, students, that's all today class. Thank you very much. Thank you for your cooperation. Bye.